Hello everyone, my name is Alexandra. I'm co-founder and CTO at Appicals. Today I'm going to talk to you about progressive web apps, what they are, and how to develop a series of progressive web apps that can be connected with WordPress and WooCommerce. Let's dive in. Progressive web apps are a new way to deliver amazing user experiences on the web. Google describes them as being reliable, fast, and engaging. But what exactly does that mean? Well, let's get a little bit more technical. Progressive web apps have the following capabilities: offline mode, web app install banners or add to home screen, and web push notifications. With the introduction of the Web Push API, we can now send push notifications to our users even when the browser is closed. Offline mode, add to home screen, and web push notifications are all implemented using service workers. In addition, a progressive web app must be served over HTTPS and use an application shell or app shell architecture that instantly loads on the user screen, similar to what you see in native applications. In essence, a progressive web app is a single-page application written in JavaScript. But how is that different from responsive web design? We all know what responsive web design is. We take the same code and information and rearrange it to fit on smaller screens. A progressive web app has responsive capabilities in the sense that it can adapt to different screen sizes, but its unique value proposition are the features that make it app-like. In addition, last year, Forrester identified that responsive web design has reached saturation, with over 87% of digital experience makers embracing it, and that a shift in customers' expectations to prefer app-like user experiences on the web is taking place before our eyes. So why progressive web apps? Building a high-quality progressive web app has incredible benefits, making it easy to delight your users, grow engagement, and increase conversions. There are several examples of companies that have successfully used progressive web apps to improve their metrics, and you can find a lot of them on Google developers' website. I'll just show you two examples. Alibaba.com built a progressive web app that led to a fast, effective, and reliable mobile web experience. The new strategy delivered a 76% increase in total conversions across browsers and a 4 times higher interaction rate from add to home screen. In another use case, OLX wanted to re-engage mobile web users by using add to home screen and push notifications. They increased engagement by 250% and improved other metrics too. The time until the page became interactive fell by 23%, with a corresponding 80% drop in bounce rates. Monetization also improved, with click-through rates rising 146%. Since e-commerce is one of the main areas where a progressive web app can bring immediate benefits, let's see how we can build one on top of WordPress and WooCommerce. First of all, being progressive is a score, not a yes or no, and there's a Chrome plugin called Lighthouse that you can use to measure that score. Lighthouse generates a report with all the progressive web apps capabilities. Basically, it's telling us what we need to change in order for a web app to become fully progressive. Moving on to technology. You've probably realized from the list of features that I already presented that progressive web apps are framework agnostic. Many are built using AngularJS or React, which are the most popular JavaScript frameworks at the moment. They both have their advantages. The Angular-Ionic combination is pretty popular nowadays. Ionic is a great framework that was originally built for mobile apps but has expanded to progressive web apps and even desktop applications. React is really intuitive and easy to understand, and benefits from a great boilerplate called Create React App, which comes with progressive web app support by default. Besides these two, Vue.js is also gaining in popularity. The examples I'm going to give in the next part of the presentation are based on React. When it comes to building an application, the first thing we need is an API from where we can retrieve the data. Fortunately, the inclusion of the REST API in the core has opened the door for using WordPress as a backend. In addition, for e-commerce apps, we can use the WooCommerce REST API. WooCommerce also has an NPM package for making API calls, but unfortunately this package requires both the consumer key and consumer secret in order to authenticate requests. We would have a major security issue if we use the consumer secret in a front-end application. Also, when creating keys from the WooCommerce admin section, it's not possible to specify permissions at the root level. For example, allowing view access for products and write access for orders. So, the first thing that we did was to create a proxy, a gateway in our WordPress plugin that allows access to a restricted set of API endpoints. As a base, we use the WooCommerce REST API PHP wrapper. As you can see in this very basic example, we first initialize the WooCommerce client using the consumer key and consumer secret. The methods below are creating a custom root called products and map that root to product categories from the WooCommerce API. In this way, we can allow access to reading categories and products and allow only the create operations for orders. Once we have set up the API, we can start working on our React application. After installing Node.js and NPM globally, you can use the Create React App boilerplate to quickly generate a React application that has progressive web app support by default. This is a screenshot of the application that is generated by Create React App. As you can see, it has everything that we need for us to start coding, including live reload. When it comes to organizing the application, I prefer to use a folders by feature structure because it allows better scalability. Also, I always add linters and a coding standard from the beginning. It's really useful to have linters because they help clean up unused dependencies and make sure that the data is properly validated at the component level. I also prefer to keep components files small, which makes them easier to test and manage. As a rule of thumb, you can start by writing code to a single component, and once it gets bigger, divide it into smaller components. For UI/UX components, there are several libraries that are compatible with React, such as Material Design, Semantic UI, or even React Bootstrap, just to give you a few examples. These libraries contain a set of ready-made components, such as grids, menus, cards, buttons, and so on, that we can immediately start adding to the application. Here is an example of an e-commerce application built with Semantic UI. On the screen, you can see a list of categories, a list of products, and a side menu. Let's dive into the code, and you'll see how easy it is to create this application by using React. Here is a React component that reads a set of products categories from the API. The component state is initialized with an empty list of categories. In the component will mount method that is automatically called by React before render, we make a request to fetch the categories and we add them to the state after receiving the response. As you can see, we don't need to call the render method when the categories are received, because React takes care of that for us and re-renders the component. In the render method, we just return another custom component called categories list that receives the categories data and looks like this. As you can see, this component iterates over the list of categories that it receives as a prop and calls another custom component called category card to render a single category element. All these components communicate by passing props between them. The main categories component calls the API and passes down a list of categories to categories list, which in turn passes the categories details to the category cards. The problem with this approach is that sometimes we have data that needs to be managed at the top application level. For example, a list of products that were added to the shopping cart. The number of products is shown on the shopping cart icon from the header bar, but these are also displayed as a list on the checkout pages. If we add all this data in the parent application component, it will become very difficult to manage on larger applications. In comes Redux.js, which is a library used for managing the global app state. Using Redux doesn't mean that we can't use state or props at the component level. So Redux should be used only for retaining data that makes sense at the application level. Let's see how we can read products from the API and render them in a list similar to what we did with categories, but this time using Redux. First, we need to make the connection with Redux by wrapping our main app component into a global store. In this example, the global app store will contain a list of categories and a list of products, which are merged together using the combine reducers method from Redux. Then we continue by defining Redux actions, which are very simple functions that return objects which must contain a type property. Since JavaScript is asynchronous, we'll need two actions. One for signaling when a request is sent, and the other for signaling when a response is received. The whole app will know when these actions take place. Below, we have also added a function called fetchProducts. As you can see, this function dispatches the requestProducts action, calls the API for retrieving products, and dispatches the receiveProducts action when a result is received. To modify the app state, we'll add a so-called Redux reducer. The reducer is just a function that listens to particular actions and changes a portion of the global state, in this case the list of products. This reducer doesn't do anything when receiving a request product action. It always returns the current state. For the receive products action, the reducer returns the data that is passed to it. In this case, it will be a list of products. To wrap things up, we use these actions and reducer in a new products component. This component is wrapped in the connect method from Redux and just dispatches fetch products in its component will mount method. Also, the component includes a product list, but as you can see, the product list component doesn't directly receive the product data. That's because the product list component is directly linked to the global app state, also using Redux. In this way, it can access the product data directly from the App Store, iterate over the list of products, and use a product card component to render a single product element. So far, we have seen some examples on how to display data. But what if we wanted to add user interactions? For example, adding a product to the cart. In this case, when the user clicks the Add to Cart button, we will dispatch an action that will modify the global app state. The header bar, which displays the number of cart products, will be connected with Redux. It will count the number of products saved in the application's cart and update itself accordingly. These are all very basic examples to get you started, and you're probably wondering how exactly we can link this application with WordPress. Well, since this is a fully front-end application, we can always host it on a different subdomain and let it connect to the API. Or we can use it as a WordPress theme, meaning creating a very basic theme with an index.php file that will just load a JavaScript and CSS file. The Create React App boilerplate includes commands for creating the application's build, so we can get the production files immediately. In the final part of the presentation, I'm going to talk a little bit about more advanced features such as offline mode and push notifications. For offline mode, we can add a service worker that will display the app shell even when users are offline. The service worker is just a JavaScript file that registers itself in the browser. There are several strategies that you can use for offline mode, such as network first or cache first. And you can read about these together with examples on the Google developers website Offline Cookbook. Caching the application's shell also has benefits even when we have a network connection, because the app will load much faster. If you want to go even further and start caching the data that comes from the API, you can use NPM packages such as Redux Persist and modify your app to save retrieved data from the browser's local storage. For web push notifications, I recommend taking a look at the OneSignal free WordPress plugin. This plugin also works with responsive themes, so you should definitely check it out immediately. This concludes my presentation. On GitHub, you can find the source files for the app I just presented. Thank you for your attention.